Okay, so hi everyone. Today we are going to learn how to work with vectors. So this is in your X3 book, the chapter vectors. Shall we start with the first part? We are going to learn first about the vector product. Okay, so before we go to the vector product, you need to already remember what you have learned in the P4 book called the scalar product or the dot product of two vectors, right? So the scalar or the dot product of two vectors A and B is written as A dot B and is defined as A dot B equal modulus A modulus B cos theta. Do you remember this? This is something you learn in P4. If you have two vectors AB, the angle between the two vectors is theta. A dot B is found as modulus A into modulus B into cos theta. This is the formula you learn in P4. Okay. So then scalar product is the scalar product gives a number. It gives a number, and it's useful to define a scalar, a second type of product that gives an answer as a vector. Okay. So then in the P4 book we learn how to find the scalar product. In this book, in the F3 book, we are going to learn how to find a second type of product, and that's called the vector product. Okay. So the vector of cross product of the vectors A and B is defined as A cross B. Look at this. The vector product or we say the cross product is defined as A cross B, and this is defined in this manner. Look at it. This is really important, and this is the main one of the main equations in our lesson. A cross B equals modulus A into modulus B into sine theta into n hat. Modulus A, modulus B, sine theta into n hat, where theta is the angle between A and B. Right now, theta is the angle between A and B, and n hat is a vector. N hat is a unit vector perpendicular to both the vectors A and B. Okay, so the cross product A cross B is equal to modulus A modulus B sine theta into n hat. So this n hat is a unit vector. Basically, what's a unit vector? A unit vector is a vector that has length 1 unit. Okay, the length is 1 unit, and the importance of this n hat is it is perpendicular to what? Not just one, but to both A and B. So the n hat vector is perpendicular to both A and B. Do you see the way they've drawn n hat here? So when you have A and B, the vector n hat is perpendicular to both of them. Okay. And then there's one more thing here. The direction of n hat. Now they've given you this right hand rule to determine the direction of n hat. Okay, so then they've given you this rule. So I'm going to teach you this rule in a more simpler way. Rather than using the fingers, we can do this in a more simpler way. However, before I go into that, I just wanted to know about this particular rule. The vector product is not commutative in the sense if you have A cross B is not equal to B cross A. Okay, so A cross B is equal, write down this rule, it's equal to minus A cross B. I will show you how these rules work with an example when I go to the next part. So these are some important things. A cross B is equal to minus B cross A. A cross B is equal to minus B cross A. So if you change the product, you need to produce a negative sign. Okay. So let's see how to use this right hand rule and how to work with these vectors. Okay. So let me show you a method how to work with these rules. Okay, so let's say now you know our cross product rule is A cross B equals modulus A into modulus B into sine theta into n hat, right? This is the rule. Okay, so let me explain you something like this. Now let's say I'm going to take the, let's say we are going to consider the product of, say I want to take the cross product of I cross I. Now you know who is I? I is a unit vector along the x-axis. J and K, I, J, K. I is a unit vector along the x-axis. J is a unit vector along the y-axis. K is a unit vector along the z-axis. Okay, so if I use I cross I, you will notice that I cross I are, these are two vectors that are what? Parallel, perpendicular. What do you think? That word. Both are I, which means they are parallel. I cross I means both are parallel. So that means what's the angle between two vectors that are both I? 0. both are I. Do you have a specific angle between them? No. So the angle between the two vectors is 0. So do you see what's going to happen here? Modulus A. Who is modulus A? Modulus I. Modulus B is also modulus I. What about sine theta? It's sine 0, isn't it? Who is sine 0? Sine 0 is 0. So do you see an important result that I'm getting here? So basically what's the important result that we derive here? The cross product of two parallel vectors. The cross product of two parallel vectors is what? Is 0. So whenever you see two vectors having a cross product becoming 0, it means those two vectors are parallel. Whenever a cross product is 0, it means those two vectors are parallel, which means automatically what? I cross I is 0, J cross J also should be 0, and K cross K also should be 0, because both are all J cross J. J and J is parallel. K and K is parallel to each other. Each of these are individually can be 0. Are you okay with me? Then let's go to the next one. What if I give you to find me something like I cross J? How do we find I cross J? Let's write down the rule. So I cross J, how does it work? Modulus I into, you see I'm using the rule here, okay? A and B are IJ. Modulus I, modulus J. Sine theta. What about the sine theta between I and J? You know, I is a unit vector along x-axis, J is a unit vector along y-axis. So what do you think is the angle between two? Maybe 90 degrees, isn't it? The x-axis, y-axis make a 90 degree to each other. So sine 90 into n hat. Okay, so one more thing if I ask from you all, what do you think about this n hat? Now, n hat is supposed to be a vector who is perpendicular to is A and B, isn't it? I gave the definition. N hat is a vector perpendicular to both A and B. In this case, n hat is supposed to be a vector who is perpendicular to both I and J. So what do you think about a vector who is perpendicular to both I and J? It is K. You know, x, y, z are three axes that are perpendicular to each other. So the vector who is perpendicular to both I and J is actually said K. Now I said here n hat is not just any vector, not just any perpendicular vector, but it's a unique perpendicular vector, which means the length is simply 1 unit. Now when you input in this value of n here, you have two options. According to this right hand rule, the value you use, now you said the value is K. However, according to the right hand rule, the unit vector could be positive K or it could be negative K according to the right hand rule. Okay, so in here the screw is now according to the way that we move. Basically, the positive or negative depends on the side that you move. So here you can see when you go A cross B, the right hand rule shows n hat is acting upward. But if you go B cross A, you can see it's acting the other way. Okay, it's negative n hat. So I will show you a easy way to get this right hand rule because it's a little bit difficult to show it from the hand. What I do is I use this. Now you understand anyway. Your n hat should be J, right? Sorry, n hat should be K, right? So now the thing is, the decision is whether you decide whether it's a positive K or negative K. So for this, I use this simple rule. I use a really simple rule here instead of the right hand rule. It's like this. If I go in this particular order, now see I want here I cross J, right? So I cross J, I'm going according to this clockwise order, I, J, K. Can you see? So if I'm going to this order, that means my perpendicular vector will be directly what K? Positive K. So basically here my I cross J will be modulus I, modulus J, 990 n hat is going to be positive K. Okay, so now let's input the values. What is modulus I? You know, modulus is the length of the vector, right? What's the length of the vector I? What's the length of the vector I? I is a unit vector, which means length is 1. What about modulus of J vector? J is a unit vector along Y axis. Length is 1 unit. Sine 90 is 1. And then you have this K. So basically, I cross J is equal to what? K. I cross J is directly equal to K. See, so this is the vector who is this is the cross product. The cross product of I cross J becomes K. Okay, let's try a few more. J cross K. Try this. Use the vector product. Use the vector cross product and get me j cross k. Okay. So j cross k, if I use the rule, look, we'll use this rule, modulus a cross b is modulus a modulus b sine theta into n hat. So like what? J cross k is modulus j into modulus k into sine. Once again, what's the angle between j and k? 90 degrees, because j and k are two perpendicular vectors, right? N hat. N hat should be a vector who is perpendicular to both j and k. Okay, so then what do we get here? J modulus j is 1, modulus k is 1, because they are both unit vectors. In the y-axis and the x-axis, sine 90 is 1, n hat. So this n hat, now if you have j cross k, a vector who is perpendicular to both j and k is definitely a unit vector, not just any vector also. Remember, not just any vector also, but a unit vector who is perpendicular to both j and k is I. So then you have decided whether it's positive I or negative I by the right hand rule. So this is my short version of it. So according to what I've written here, j cross k, you follow the arrow, which means it's what I? Positive I. Which means my answer is simply I. Okay, so then what if I go the other way? Let's try something like this. Like give you to find I cross k. How do you find I cross k? So in I cross A, k, the rule, let's apply the rule A cross B. A cross B was modulus A into modulus B into sine theta into n hat. This gives me modulus I, modulus k, sine 90, who is the n hat. Now you have decided the n hat is j, positive j or negative j. Negative j. Okay, so let's see, modulus I is 1, modulus k is 1, sine 90 is 1, what's the n hat? When you go I cross k, I think you can clearly see if you are going the other way. Which means it is negative what? J, because j is the vector who is perpendicular to both I and k. So I cross k is minus j. Do you understand? It's really simple. Okay, this rule is really easy to work with. So this is basically how we use the right hand rule. Okay, shall we go for the next part? Let's go to exercise 5A. Question number 1, part A. So 5j cross k. Okay, so 5 is basically like a constant, leave it aside. So you have to take j cross k. So actually, when it comes to this j cross k, shall we learn to write the answer in one go? Now you saw previously, I was using this formula and I was doing it. But do we need to really use the formula and do all these sums? No, right? Because so that we can get the answer like in one go. So I cross j is directly what? If you are going to the side, then the answer is directly the other vector k. If I give you k cross j, what's the answer? K cross j is going against this, so it's going to be negative y. Do you see this method? Yeah. Technically, basically, if you use even these formulas, it's the same. But you can write the answer directly in one go. So I cross k will give you what? I cross k will give you, going against it, it gives you minus j. Do you understand what's going on? So this is the shortcut. So we could use this shortcut over here. So j cross k, what do you think about j cross k? I, j, k. So when I think of this, what do I see here? J cross k is, who is it? J cross k is positive y. So the answer is 5y. Okay. Then part B, 3I cross k. Is basically a constant. Now, who is I cross k? I cross k gives you, who is I cross k? It gives you, because you're going against this arrow, you get what? Which vector? You get not just j, minus j. So you end up getting minus 3j. Part D. Means that I not j. I cross k is minus j. Okay. Then the other one, 3I cross 9I minus j minus k. The first thing is here you open the bracket with the cross product, 3I cross 9I minus 3I cross j plus 3I cross k. Do you see you use the product many times here, the cross product? So basically 3 times 9, 27, I cross I. What do you have to say about I cross I? When two vectors are parallel, the vector product will be 0. Minus 3 times, who is I cross j? Ijk, so I cross j is directly k. Plus 3 times I cross k is minus j. So I end up getting here minus 3k minus 3j. Part E 2j cross 3i plus j minus k. So open the bracket here. What do we get? 2j cross 3i plus 2j cross j minus 2j cross k. This is okay. So using the rule again, 2 times 3 is 6 and I get j cross I. J cross j minus 2j cross k. So what happens here? J cross I then going to the opposite of this arrow from j to I. So that means it's minus k. So 6 into minus k. J cross j will give you 0. Minus 2 times j cross k is I. So minus 6k minus 2i is the answer. Is this clear? Let's move to the next part. So then let's try part J also. Part J, they've given you the cross product of the two vectors in column vector form. 3, 0, 2 cross 1 minus 1, 2. Shall we write this in the normal form? ijk 3i plus 0j. So I don't need the 0j. And then 2k. 3i plus 2k multiplying with 1i minus 1j plus 2k. Are you with me? How do we expand this? First 3i, now it's a cross product here. So 3i, you have to take the cross product with the entire bracket. So 3i cross product with I minus j plus 2k. Remember, this is not just a multiplication sign. This is the what sign? It's the cross product sign. Okay, not the multiplication. It's the vector cross product that we are doing here. And then along with the 2k, again I multiply my whole bracket. 2k times I minus j plus 2k. Are you okay with this? Open brackets and apply the cross product. Ijk, you must have this. What do we get here? 3i cross I minus 3i cross j times to 6i cross k. Do you agree? Bracket plus 2k cross I minus 2k cross j times to is 4k cross k. Do you understand? I cross I will be 0 and the k cross k will be 0. Anyone who is the product with itself parallel vectors will be 0. Let's take I cross j minus 3 I cross j is positive k, right? Then 6 times I cross k is going to the other side of the arrow, which means it's minus j. 2 times k cross I is directly j. Minus 2 times k cross j is again going against the arrow, so that's minus I. Basically, you get minus 3k minus 6j plus 2j minus minus is plus 2y. Basically, I end up getting 2y minus 4j minus 3k. Is correct? 2y minus 4j minus 3k. So in column vector form, 2 minus 4 minus 3. So this is the cross product of the two vectors. So once again, remind yourself what's the cross product. When you take the cross product of two vectors, what do we actually get? We get a vector who is perpendicular to both the initial vectors. Okay. You can say that the way that we got the cross product here is actually quite tedious, isn't it? Because the amount of work now here, there was actually one element became zero here. So it reduced the amount of work. But if that was also there, then you would get more coefficients. You would have gotten not just 6, but you would have gotten 9 coefficients, which would be really tedious to work with. So then we need a easier technique to get the cross product of two vectors. Okay, so write down the topic, obtaining cross product. Obtaining cross product by using determinants. We are going to obtain the cross product by using determinants. Okay. So once again, I'll write my two vectors 302. I want every cross product of 302 along with 1 minus 1 2. So what do we do here? Look at the way how we get the determinant. So actually we say the cross product of two vectors can be found by the determinant of its respective 3 by 3 matrix. So I think you are it's quite new for you all are hearing from the determinant. You already know how to get the determinant of a 2 by 2 matrix. F1 you have learned. However, the determinant of a 3 by 3 matrix you have not learned. You will also hear about this in the matrices chapter which comes up next. Anyway, so you need to learn how to find the determinant of a 3 by 3 matrix. Okay, let's see how it's done. So what we do here is to get the determinant. Okay, the first thing you do is you mark ijk. So mark ijk. The first column is the first row is ijk. The second row you can write your first vector. What's the first vector that we are taking the cross product? 3, 0, 2. The next vector that we take the cross product is 1 minus 1 2. Okay, so this is the first thing you do is you need to use your two vectors and create a 3 by 3 you create a 3 by 3 square matrix. Ijk must be the first row and then the two vectors make up the second and the third row. Then you apply the signs plus minus. Give these three signs. I want you to apply these three signs at the top. The I should be assigned the positive sign. The J should be assigned a negative sign, and the K should be assigned a positive sign. Okay, so all these in every single sum. Whenever you are taking determinant, whenever you are taking a determinant of a 3 by 3 matrix, I is the first person here. I has a positive coefficient. Coefficient J is supposed to be negative, and K should be positive. So now look how we take this determinant actually, how we break it up. So we write here I times, the positive I times, break up the determinant, and what we do here is eliminate, just remove the row and the column with I. Remove the row and column with I. Do you see some elements remaining here? So then remove the row and column and you can see 0, minus 1, 2, 2 is remaining. Do you see? So I write I here. First I write I here and I write those remaining elements. Who are they? 0, minus 1, 2, 2. Then the next thing I do is, the next element I go to is, I go to the next person. I first wrote with I, now go to J. What J do we have here? Minus J, not just any J but minus J. And let's try the determinant. So once again do the exact same thing. Eliminate the row and the column with J. Eliminate the row and column with J. Do you see what's remaining? 3, 1, 2, 2. So that's the 2 by 2 matrix that multiplies here. So 3, 1, 2, 2. And then finally, I am done with J. Then I have to go to K. So K times, what do we have here? Remove the row and column with K. 3, 1, 0, minus 1. 1, 0, minus 1. Okay, so now what you do is quite simple. Now you can see we have 3 sets of 2 by 2 matrices here, right? Take the determinant of this 2 by 2 matrices. You know how to take the determinant of a 2 by 2 matrix, right? So what do we get here? I times inside the bracket. You first multiply along the main diagonal. So 0 times 2 is 0, then come minus in the mark, minus mark in the middle. Minus 1 into 2 is minus 1 into 2 is minus 2. Do you see how this is the way we take determinant of a 2 by 2 matrix. Multiply the two elements on the main diagonal minus, then multiply the elements on the other diagonal. 0 into 2 is 0, minus 1 into 2 is minus 2. Minus j times, do the same thing, 3 times 2 is 6, minus 1 times 2 is 2. And finally plus k times 3 times minus 1 is minus 3, minus 1 times 0 is 0. What do we get here? Minus minus is plus 2y, 6 minus 2 is 4, minus 4j, minus 3k. This is the answer I got when I did it manually. See the way the answer I got manually and the answer I get by the 3 by 3 determinant is both exactly the same. Yes. So then this determinant method is more preferable in, rather than the manual expansion method. Okay, so we normally, most of the time when we want to find the vector, when we want to find the cross product of two vectors, we obtain the cross product by using the determinant of a 3 by 3 matrix. This is the most popular method in getting the cross product of two vectors. Is that clear? Okay, let's move on.